The diagram shows a parallelogram. The area of the parallelogram is greater than 15 centimeters squared. And in part A, we need to show that 2x squared minus 21x plus 40 is less than 0. So the first thing we need to do is work out the area of the parallelogram. So the area of a parallelogram is the base multiplied by the height. Now actually what we can do, because we've been given the measurement of this length and this length, because it's a parallelogram, this is equal to this, and this is equal to this. So we can write on the measurements just to make it a bit clearer. So this is also going to be 2x minus 1 centimeters. And this is also going to be 10 minus x centimeters. So the area of a parallelogram is the base multiplied by the height. So that's this length multiplied by the height here. But we don't have that at the minute, so we need to work it out. So to do that, we're going to use a bit of trig. So if I create a divide here, what we've got here now is a right angle triangle here. I'm going to draw it out over here to make it a bit clearer. Where this length here is the height that we want to work out. This here, we've been told, is 10 minus x centimeters. So we want to work out what this angle is. So if we have a look back up at our parallelogram, this whole thing here is 150, but just this portion here, this is 90 degrees. So if we do 150 minus 90, that will give us the size of the angle. So 60. So we've got 60 degrees here. And quickly before we do the trig, I'm going to label the sides. So we've got our right angle here, which means whatever side's got the right angle and the angle, this one here, this is the adjacent side. This length here is the hypotenuse. And the one that's directly opposite of this angle is the opposite side. And we can use our friend SOHCAHTOA as a little reminder to work out what we need to do. So we want to work out this side, so A, and we've got information on H, the hypotenuse. So we need to look here, which one has A and H. It's going to be cos. So this is basically saying that cos of something is the adjacent divided by the hypotenuse. So in our case, we're going to have cos of 60. It's going to equal A, which is our unknown we want to work out, divided by the hypotenuse, which is 10 minus x. Now if we put cos 60 into our calculator, we get that that is a half. So you've got a half equals A divided by 10 minus x. And we want to get A by itself. So if I multiply both sides by 10 minus x, we get that these cancel, leaving us just with A. And on the other side, we're going to have 10 minus x divided by 2. Fantastic. So we now know what this height is. It's 10 minus x divided by 2. So we can now use our area of a parallelogram to work this out. So we're going to have the area equals the base, which is 2x minus 1. And we're going to multiply that by the height, which is 10 minus x divided by 2. So if we sort of combine that into one fraction, we're going to get 2x minus 1 multiplied by 10 minus x on the top. And we're going to divide that by 2. So now I'm going to expand out the brackets at the top. So that basically means multiplying every term by every other term. So if we do 2x multiplied by 10, that gives us 20x. 2x multiplied by minus x, we get minus 2x squared. If I do 10 multiplied by minus 1, we get minus 10. Minus 1 multiplied by minus x, we get positive x. And it's still divided by 2. I'm just going to tidy it up and rearrange it a bit. So we've got the x terms. So 20x plus x, that's 21x. And then we've just got the minus 2x squared and minus 10. So if I write it like this, we've got minus 2x squared plus 21x minus 10 divided by 2. So now we're told up in the question that the area of the parallelogram is greater than 15 centimeters squared. So we can create an inequality. We can say that minus 2x squared plus 21x minus 10 divided by 2 is greater than, so this symbol here, 15 centimeters squared. So if I multiply both sides by 2, we're going to get that minus 2x squared plus 21x minus 10 is greater than 30. If I subtract 30 from both sides, we get minus 2x squared plus 21x minus 40 is greater than 0. What we need to do now is if we multiply both sides by minus 1, we get 2x squared minus 21x plus 40. And on this side, we'll just get 0. we need to remember if we multiply an inequality on both sides by -1, we need to flip round the sign. So this is now going to be less than the sign. And that's great, because if we have a look back up in the question, we needed to show that 2x squared minus 21x plus 40 is less than 0. And that's exactly what we got to here. So we completed this part of the question. We got our first mark here. So for going through this process and getting down to this, where we're starting to work out the area. The second mark for a correct expansion of the brackets on the numerator. And the third mark for obviously getting down to the correct answer, but going through this working and realising that we need to flip the sign and things like that. And part B says we need to find the range of possible values of x. Okay, so this is what we're working with at the end of part A. So the first thing we want to do is factorise this. So essentially put it into a set of brackets like this. So if you look online on the Physics and Maths Tutor website, there'll be lots of other examples and help with learning how to factorise things like this. But in this case, we're going to have 2x and x here. Because we've got this 2x multiplied by this x, giving us 2x squared. And here we're going to have -5 and -8. So if we multiply these together, we get the plus 40. If we multiply this term and this term, and this term and this term, and add them together, we get this. It is sometimes tricky to work this out, but with practice it gets easier. Yes, it's worth a look at the other resources available to learn how to do that well. For a second, we're just going to imagine that this set of brackets, we're going to set it equal to 0. And we can use this to get what's called our critical values. So when two things multiplied together equals 0, the ways that could happen is either this bracket could equal 0 or this one. So first, if we imagine this one equals 0, we got 2x minus 5 equals 0. So 2x, if we add 5 to both sides, 2x equals 5, x equals 5 divided by 2. And if we imagine that this one equals 0, we're going to have x minus 8 equals 0. So x equals 8. And these here are our critical values. I'm now going to do a little sketch here of the quadratic. So if we imagine this is our x-axis, and we've got 5 over 2 and 8. I'm just going to put the sort of relative positions. So here we're going to have 5 over 2, and 8's greater than that, so I'm just going to put it over here. Now we're going to have a rough sketch of the quadratic. We need to look at our x squared term and see the coefficient. Is it positive or negative? If it's positive, we're going to have a happy face like this. If it's negative, we're going to have a sad face like this. But in our case, it's positive, so we're going to have a happy face going through these points. So we have 1 through here and 1 through here. Now we need to look back to our inequalities. We can see we're looking when our quadratic is less than 0. So if we imagine we have our axes here. So when y is 0, it's this line here. So it's anything below this line. So this part here. So when is our quadratic less than 0? Well, it's when x is between 5 over 2 and 8. So our range of values is 5 over 2 is less than x, which is less than 8. So we get our first mark for factorising, we get our second mark for the critical values, and the third mark for the correct range.